Hello everyone, and welcome back to our second part of our tree animated tutorial, where we in this part will learn how to export our animated tree that we created earlier in our previous video inside Blender, and how to import it inside Unreal Engine and use it to produce an ArcViz animation videos. So let's get started. So inside Blender, after we have created the tree using M-Tree add-on and parented to an armature that was animated using a reference by adding a wind and simulating that movement using cloth simulation. Part 1 will be included in the description if you have missed that part to be able to carry on with this tutorial. So the next thing before we export our tree to Unreal Engine is that we need to add a vertex color to these leaves to be able to use the simple grass wind inside Unreal Engine, and this will also add a small simulation of movements to these leaves so we can make our tree more realistic. To add these vertex color, we're gonna paint it over our leaves. But to give you a heads up, if you have these leaves actually containing the vertex color and then you have updated your tree, that vertex color will be translated to all of these leaves. But even though if we haven't done that, and this is the same situation now, we will create this vertex color onto these leaves and then translate it to the other leaves. How we gonna do that? Simply, we're gonna go to that vertex paint mode, and as you can see now, it's in white. The idea of the vertex color movement is that the white will be the part that will be moving. So we're gonna start by adding a black color, paint, set the vertex color, so now all of them are black. Now we're gonna paint the parts that we need them to be moving. So we're gonna paint the end of these leaves or half of them, and basically make sure that this leaf object or the model that you have used to create these leaves are one surface object. Because if you have a double sided objects, like for example this branch, the movements will be a little bit weird and it will not give you a nice result to these movement. So now that we have finished most of them now, the next step is we need to translate this vertex color to the other branches that we have created. So to do that, let's go into object mode and then select all, deselect that branch that we have added the vertex color to, then select it back in, and then Control L and choose link object data, and this will basically translate all the data from this branch to the different. Just to make sure, just choose one of these branches and you'll find that the vertex color are included now. So that's number 1. So it's here also, just to make sure. This is step number 1. Step number 2 is that we need also to make these vertex to be object separated. In other words, basically when we have created this, they were instance of this branch, and we need to detach this relationship so each one of them will have a single entity. If we export the tree right now to Unreal Engine, inside Unreal Engine each branch will be shifted from its origin location because they are not into scale. If you apply, for example, the scale onto this branch, for example, you'll see that Blender is telling you cannot apply a scale to that object. And all of them actually, if you hide the other objects and select them all, Control A, apply scale, you'll get this message. And this is because they are still instance of this leaf. And if we apply the scale to the branch, to the trunk itself, you can see that it's working fine, except for these branches. So we're gonna select them all and go to the object, then relations, make single user data, and we will select object and data. Don't select object and data and materials, just select the object and data. And now they are actually separated. So if we apply a scale, we'll see now that it is possible to apply the scale. So these two important steps will help us overcome a lot of issues later on. So we're gonna select our tree and export it as an FBX. The FBX format is basically the best option to export an animation to any other softwares. We have tried Datasmith, but actually it doesn't support actually a skeletal mesh, which is the armature in our case. And Alembic is also good, but the problem is the Alembic files get really big and the sizes makes it very difficult to import it. So we're gonna stick to FBX. We're gonna select our object. We have armature and mesh only. The scale, because we have an armature here, it's better always to set the scale to 0.01, because this will help you overcome also another issue for the armature scale inside Unreal Engine. The local axis up direction will be Z and the forward will be X, and we will apply our unit. So the geometry, we're gonna put the smoothing to face, and the armature, keep the apply modifier, it's fine. And for the armature, make sure to uncheck the add leaf bonds, because we don't add more bonds to our armature. We're gonna choose root, and then for baking the animation, we're gonna select only key all the bonds of this animation, and then we're gonna export this to Unreal Engine. So after the export have finished, we will also create another tree, but a one that doesn't have an armature or an animation. Basically just a basic tree where we're gonna take advantage of the vertex color, so we can have it also in an animation mode inside Unreal Engine, just to put it in the background like a paint tool or something that we can distribute tons of them around the scene. So to do that, we're gonna delete this tree, and then hit create. But before that, make sure to pick the leaf that we have adjusted, because in memory it still have the older one. So once we create this, we're gonna have the tree along with the branches that have the vertex color. Then we're gonna export this the same way, but without the armature or the animation option, as an FBX format. So inside Unreal Engine, to import our previous one, which has the armature, make sure to import this by using an import into level. So inside Unreal Engine, this is Unreal Engine 5, the import option of FBX is divided in two ways, either by using the one that's inside the content browser, but don't use this if you're importing a multiple object that have a specific location of the objects. Otherwise, you're gonna end up having all of your objects inside the content browser, and you have to find a way to arrange them inside your level. So import into level is a much better way to do that. So once we hit import, and let's create another folder, for example tree 3. Once the import process will start, a window will appear before finishing up the import, which you can see a hierarchy type for this import process. We usually go on with the create one blueprint assets, as actually proven that it's better than the other two options. And to make sure that you have all of your trees, just click on the arrow here to see all of the other hierarchy. And inside the static meshes, make sure to have the vertex color in replace mode. So we want to replace what we have to what the Unreal Engine will import. And inside the skeletal meshes, make sure to check the animation, set your animation, or keep it as an animated time. The import time of this file will depend on your PC specs, along with the memory and the CPU speeding process. So after the import will finish, you're gonna get your tree imported inside the level. So we did that already, but just to give you a heads up, once the import finish, once you have your tree available with all the assets that came with it, it is really recommended to drag the armature on top of the default scene root. So basically the armature will become your root. So this will help you actually to move your tree inside the scene before. But let's drag the tree into our scene to see what's gonna happen once you import it in. Alright, so when the import will finish, it will come, for example, at this size, because if you remember, we have set the size to a smaller scale to fix an issue that we will see right now. So our tree is composed now of skeletal meshes and static meshes. The static meshes are the part of the tree that doesn't move. The skeletal meshes are the part that have animation inside of it and need to have this animation assigned inside the animation mode. So basically, the tree that we have, let's hide the grass for now. So once the import process is finished, you can see that the scale is a little bit smaller. So we can increase this scale, and you'll find that currently the tree, if you hit play and try to see if the movement is happening, for example on the tree, you can see that the tree is not actually moving because the animation is not fixed on the model yet. What I mean is, if you export that FBX format, or if you import it inside another software like 3D Max, for example, you'll find that the tree is moving exactly the same way inside Blender. But inside Unreal Engine, every FBX object that have animation, when it get imported, Unreal Engine will create a skeletal mesh for the object that have animation file, and create also animation file with the same name of that skeletal mesh. For example, we have here twig, which is one of the branches, along with its skeletal meshes. Now the problem right now is, if you look at the number of the skeletal meshes, they are more than 1000 actually. The number of them, the way to go on each skeletal meshes and inside the animation mode, and to set up each one of them to use animation asset and call the animation of that skeletal meshes, will take hours to fix it. So we had to find another way to do that, because currently this is impossible to work with. And the only way to solve this was using a Python code. So we called our friend Ahmed Naguib, who is really a Python specialist, and we asked him, is it possible that the Python can actually assign these animations of each twig automatically inside Unreal Engine? And the answer was yes. He told us that inside the Unreal Engine API index, which is the index of the Python as was set up by the Unreal Engine, there's a lots of possibilities where you can use Python to overcome some issues inside Unreal Engine. So Ahmed have created a code for us that was really magical in terms of how to solve this inside Unreal Engine, or even how to use Python with Unreal Engine. And hopefully he will join us in the future with a video, for example, to see how we can use Python with Unreal Engine, especially in architectural visualization. So let's see what he exactly did. Based on what Ahmed described for me, he started the code to set up a selection way of the entities or of the objects inside the level. So the Python will first analyze the selected object, which we will select. As you can see here, before running the script, select all content in the content browser, which is this one. We have to select them all, Control A, and then select actor and the world editor, which is this one. But before that, let's also remind you that you have to enable Python inside your Unreal Engine file. So once you enable Python, it will ask you to restart. So you can enable basically Python to be inside your project file. So inside Unreal Engine 5, they have relocated the execute command for the Python script and under tools, but in the previous versions you'll find it in the file menu. So again, with the code that Ahmed have created, you'll find that he started by selecting, this is what he described for me actually, get selected assets. So the code will analyze what is selected basically, and it will give us the name of that actor, and then it will start combining, or as far as I understand, assigning the animation files inside the content browser to each skeletal meshes that the Python have found. So let's run the script and see how it's gonna go. So I'm selecting now the actor, which is the tree, and now all the content browser, basically all what is there inside the folder that we have imported our tree, and then execute the Python script, which you will find in the description below in the GitHub page of Ahmed. So I'm gonna select the Unreal Engine assign animation, open it, and in a fraction of a second, it's done. Every skeletal meshes have its own animation assigned in less than 2 seconds. This is really useful to any skeletal meshes or any objects that have lots of skeletal meshes with animations. Let's say, for example, a car or even a robot or anything, and you can actually use this for that. Thank you, Ahmed, for creating this script, and you'll find a link in the description for his GitHub page where you can download the script, and also his LinkedIn page if you wish to contact him and ask him about anything regarding Python. So now if we hit play, you can see now that the animation that we had inside Blender is now happening also inside Unreal Engine. Next is the material. Okay, so to edit the material, the good thing that we have a bridge available from Quixel Mixer to download as many leaves textures as we need, and each texture, for example, if we go to the home atlases, it's under actually Vine, you'll see lots of leaves textures which Quixel have prepared along with their let's see what we have here. You'll see that each one of them have a diffuse or albedo, ambient occlusion, opacity, normal. They all are there. So all you need to do is go inside Blender while you're modeling actually the tree, and then use these textures to assign it using the UV editing on top of these leaves. And inside Unreal Engine, once you import, for example, these textures in, let's find the leaf material that we have created in Blender, and let's assign these textures. So the material have to be set to blend mode to be masked, so we can have the opacity, and also we need to have it on a two-sided foliage, and make sure to select the two-sided so we can have the material visible from both sides. So we will start by the albedo connected to the base color, and we have also the reflection texture. I'm gonna connect this to a multiplier and a scalar parameter. If you're not familiar with the Unreal Engine material, you'll find the link in the description for a material tutorial that we have created earlier. So we're gonna connect also this to the reflection, and also we're gonna use this texture also to connect it to the specular and also to the roughness with the 3 scalar parameters that will help us to control the value, and also the opacity node to be the opacity mask. And then we have also the normal texture, which we connected also to a flattened normal to give us control over the normal of that leaf. And then we're gonna connect a subsurface color. This is basically the way you can simulate how the leaf will look from the back when the light hit it. It's basically a trick to simulate that the leaf is showing the light going through it, but it will give you a nice result in terms of a texture for the leaf. Now the last step, which is the vertex color that we have talked about inside Blender. Now because we have a vertex color built inside that leaf object, we just need to call the node vertex color and connect it to the wind weight, and call the symbol grass wind and create these 3 scalar parameters that represent the intensity, speed, and also the weight. Make sure to have a smaller values at the beginning and connect this to your world position offset, which will enable the movement of the leaf. You can start to see now that there is some movements, and if we apply that now, so if we hit apply now, we can see that the tree, let's get a little bit far from the camera, and this is camera 1, so inside camera 1, we'll just adjust the focus distance to the tree. Now you can see that without even having the animation of the tree, there are some movements on the leaf using that vertex color, and this is very useful. We gotta import that tree that doesn't have actually animation, and you can basically use the normal import option, and make sure again to have the vertex color in replace mode. So once the import is finished, we're just gonna copy the materials content of that tree and apply it to the one that we have imported as well. So once the material is applied, we'll go to the paint panel, foliage paint panel, and let's get out of the camera, go to the perspective, and this is the part where you can start adding more trees to your surrounding around the house, because this is basically a very light model of the tree than the other one. So we're gonna select this, make sure that the grass is not selected, and we're gonna paint using a single node, and let's bring the scale a little bit down, 0.4 for example, 2.5, so we have a variation of that. So we can start painting over here. It will just take it a second to load the material. Okay, so basically just randomly around the area until you get a sense of the idea of having these trees around the house. Once we are finished, we can now start to set up our camera. Let's move to camera 1 for example. Then we can create, for example, a small animation using the animation sequence. For example, if we go to here, right click, animation, level sequence, cam 1 for example, and then add a track, for example, go camera 1, hit transform as the starting point, and at the end of this, let's move, for example, a little bit to the right on this part and hit transform. So we have the camera movements, and now we want to render this into a higher resolution render. So previously we were using the render sequencer to produce the images or the videos, but now inside Unreal Engine there's a better option where you can use also the cinematic movie render queue. So I'm gonna add the cam 1, and let's click on the settings. Let's choose, for example, a PNG, as it's contain more data than the JPEG, and the output is basically the location you will set the images to, set the resolution, and a couple of things you can do to improve the render quality. Let's add a console variable where you can add, for example, like a texture streaming console command. This will enable Unreal to let all the textures stream without any limitation. Currently I'm leaving this on this level so it will not crash the engine. Let's add another one, for example, which is a screen percentage, for example, to increase the resolution. So this can be screen percentage, and let's give it a 200, for example, or a 300, as you wish. but make sure to start, for example, to a lower value. So because our resolution now, or our percentage of the screen, is 100, so if you set it to 200, you're basically getting more quality out of that. And let's also add an anti-aliasing, and let's override the anti-aliasing here, give it a value, for example, to 16. This will enable more crisp image on your render. So after that, just hit accept and start the render process. Now this will help you to produce a high quality animation for your project, as we have done in our example. As you can see in the beginning of this video, we were showing this video as a result out of this animation. So hope you guys find this useful for your ArcViz project animation, where you can produce these high quality animated trees. The major drawback of this technique right now, the problem is the frame per seconds for these trees. If you increase the numbers of the skeletal images, or basically the number of the branches, it creates a very large amount of memory requirements. So we're still trying to figure out a way to minimize this memory leak or memory usage for this tree. And for now we can use the other tree that we have created for the background as our animation and the gameplay mode. Or if you, for example, spend more time to minimize the amount of data inside the tree inside Blender, hopefully you will be able to have this tree. Sorry, I'm not able to select because I'm in paint mode. Hopefully you will be able to create a tree inside your game mode. But for now, it is really useful to use this technique to create a realistic animated tree that you can make a close-up approach for your camera lens and create these awesome videos for your project. So if you have any questions, please mention it down in the comments. Again, Ahmed Murad Python script is available in the description in his GitHub. Download it, use it, and also if you have any questions, don't hesitate to contact him. Along with that, you'll find a link for our other previous tutorial that will help you to produce this tree. Also we'll put a link for that tree in the description below, a Blender file where you can download and test it in your project. So thank you very much for watching. I hope you guys enjoyed this tutorial. Please share your comments, and if you have any questions, please share it with us. We are very grateful for you taking the time to see this tutorial. Thank you very much, and see you in the next time.